All right, welcome back. The next pattern we'll talk about is called the sliding window. So this really is useful when we have a set of data like an array or a string again, and we're looking for a subset of that data that is continuous in some way. So for example, here's a string. And if I asked you to write a function to find the longest sequence of unique characters, so you would start, let's see, well, we've got HEL. Those are 3 unique characters in a row, but then we hit another L right here. So this is the longest one we have so far. ELL, nope, that's not going to work. So then we could look at LOTHER, and that looks like it's going to be our longest string of unique characters, unless I'm losing my mind here, because then we hit this E. So anyway, this is one example of a problem we could solve with the sliding window approach. The other one I'm going to show you has to do with finding a max subarray sum. So we pass in an array like this, and then a number. And we're trying to find the max sum of 2 digits that are next to one another. Or in this case, 4 digits that are next to one another. So this would return 10 because the 2 digits next to one another that have the largest sum are 8 and 2, which is 10. Anyway, we'll come right back to this. So what we do is we make a window, which can be a single variable, or it can be a subarray, or even another string if you wanted to. And we move that window depending on a condition. We slide it up, usually from left to right. If we start at the beginning, you could go from right to left. You could start in the middle, I guess. But usually we move the window from the left, the beginning of the element, or the beginning of the array or string towards the end. And sometimes we might make a new window. So I'll show you what that really means. But it's useful in these problems where we're keeping track of a subset of data in a larger set of data. So back to this problem. Write a function called max subarray sum, which accepts an array of integers and a number called n. So it doesn't have to be sorted, the array. This is just any integers in an array. And then we pass in a second number, as I already mentioned, and your function should calculate the maximum sum of n consecutive elements in that array. So whatever we pass in here, like I already showed you, 2 should return 10 because 8 and 2 is the largest sum of 2 consecutive numbers. Here we have 4. Well, what's the largest sum of 4 numbers? We know it's 17, and I believe I think it's these 4, right? That's 7, 8, 9, 17. And it's close because there's, this subarray here gives us 16, I believe. Is that right? And we've got this one here, which also gives us 16, but this one is the largest sum of 4 continuous consecutive numbers, which is 17. Also, in an edge case, if it's empty, it should return null. Anyway, that's the problem. And to solve it, there's a couple approaches. Of course, the naive version, the simpler version, is basically to start right here. Let's actually go with this example, 4. Start right here in a loop, and then have a second loop that looks ahead and sums together 4 items. And you create a variable to keep track of that sum. So what is that? That would give us 7, 8, 9, 10. So we'd start with that. And then we move forward 1, and we have a new sum starting from here, and we add these 4 together using another loop, and then we compare that to the sum we had before. We take the maximum, and we keep track of whatever the maximum is. And then we would move forward from here and try with the second loop, 1, 2, 3, 4, and sum that together, and we keep doing that. And I have that solution right here. So I'll copy it over, and let's just quickly walk through it. When we call it, the very first thing we do is just make sure, once again, an edge case, if the number is greater than the length of the array. If we're trying to find the largest sum of 3 consecutive integers and there's only 2 in there or 0, we just return null. Otherwise, we make max. And I started it at negative infinity because I wanted to account for if we had an array that was all negative numbers, our biggest sum would still be negative. So starting it at 0 doesn't really help. Unless we're only working with positive sums. So I did negative infinity. That's not a huge deal. So then what we do, I should mention, we take an array and a num. This is the number of digits we're trying to sum together. And I create a loop. So this loop starts at 0. It goes until the end of the array, well, almost to the end of the array. And I'll show you where it actually goes. What we're doing here is if we're looking at 3 digits in a row, we're going to start here and add these 3, and then add these 3, and keep going. And we don't want to go all the way to the end and try and add 2 more digits together. We don't want to go here. we want to stop here so that we hit the end of the array with our sum. This is the last place we could start our sum, if that makes sense. If we're looking for 3 digits, if we're looking for 5 digits, this is the last place we could start. So that's what this is doing here. And then we add one to I. Okay, so if we're adding 3 digits together, that first loop is just going to start a loop here, and then we'll go to here, 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 and stop right here for our last sum. Then what we do is make a variable called temp. Temp is just going to start at 0. We have max, and so temp will store our sum each time through. So we'll add together these 3, and then add together these 3, and compare it to max. And then add together these 3, and if it's larger than our current max, we'll update max to be temp. So that's what I'm doing here. So our second loop goes through j equals 0, j is less than num, j++. So num is the number of digits. So we have I starting here, and then this second nested loop right here that is going to look ahead and add 6 to 2, and then add 9 into our temp variable as well. That's what this is doing, array of I plus j. So we're at I, and then we add I plus j, where j has gone up by 1 index, which is just a way of summing these 3 together. Then we check if temp is greater than max, max equals temp. So we update max if our temp sum is larger. And the very first time through, max is negative infinity. So no matter what we do, we'll be updating max to be these 3 digits. And why don't I just print out our state of, let's do console.log temp, and then also max, like this. And when I call my code on this subarray, or on this array, I mean, you can see that we start off, first couple times, we have 17, the first 3 digits, sum to 17. And then actually again, we get 17. Then next time through, we're looking at 9, 2, and 1. So that gives us 12. So we don't update max. Max is still 17, but temp is 12. Then we do these 3, 11. These 3 gives us 14. Then we get to here, and now we hit 19. And this temp is now larger than the old max. So we update max to be 19. And then that is our max for the rest of the array. And we return 19 at the end. So let's talk about what's not good with this solution. So it doesn't seem like this nested loop is that big of a deal when we're talking about 3 items, when we're only trying to sum 3 things together, and that's true. But if we had a really long array, which I'll type up real fast, let's say we have this massive array, and we're trying to find the largest sum of 20 consecutive digits. What would happen is that we have this first loop, I, that's going for every single item, or almost every single item. Technically, it doesn't go all the way to the end. It stops, 20 digits before the end? But we go all the way through, and each time we're summing from the beginning 20, I'm just going to guesstimate 20 or so digits. We're going to sum 20 together. And then we're just going to move forward 1 and loop 20 times again and add them together. And we keep going. And this can be really inefficient, especially 20 is still a very small number in the grand scheme of things. If we had a huge array, remember with big O notation, we'd take things, extend them way out towards infinity. So let's say we have 1,000,000 items in here, and we're trying to find the largest sum of 10,000 or even 100,000 digits in a row. It's really inefficient to continuously do this and update, and now add together another 100,000 digits, and then move forward 1, add together another 100,000 digits. It's just not efficient. And a rule of thumb is you can just say it's n squared anytime there's nested loops. So there are better ways of doing this, which is where our sliding window approach comes in. Dum-da-da-dum, here's a sliding window. All right, so here's how this one works. I'll just copy it over. First thing you can see, though, it is O of n. It's linear complexity. We only loop 1 time. Well, technically, there's 2 loops written down, but we only go over the entire array 1 time. So let me show it to you. Here it is. What we do is at the very beginning, we sum together the first, if we're looking for 3 digits in a row, we sum together these 3. And then rather than starting a loop here and summing together these 3, and then starting again and adding 3 together again and keep going like in that fashion like we did in the last solution here, what we do is we keep a variable that just has this total right here. And all that we need to do to figure out the next sum of these 3 digits, we don't have to re-add 6 and 9 and 2. We can just subtract this number and add this number. Or to give you a better example, if we go back to this massive array, let's say I'm summing these digits together. If I want to figure out this sum that comes after it, starting from this 2 instead of this 1, let's do something slightly more manageable. Let's say I'm going from this 1 up until this 4. I don't have to re-add every number together to calculate this sum. All that I have to do is subtract the 1 and add the 5. So that's the sliding window. We're going to create a sum that goes from here up until, let's just say, here. And then to slide it over, we don't recalculate everything. We just subtract this number. So we move the window up like that. And then we add this number in. So that's what I'm doing here. If I get rid of this massive array again, and we hop back, we have this max sum and temp sum. And I have my edge case. If it's an invalid array and we're looking for, a number that's too large, we return null. Then we create our first sum. So let's say I pass in 3. Okay, that works. We're going to just start at the beginning and sum together the first 3 digits and store that in a variable, which is called max sum. And that's it. We don't keep looping. So we just loop 3 times and add them together. Then I set a temp sum equal to max sum. So we just have these 2 variables, and max sum is what I will return at the end. Now what I do is I start another loop, and instead of starting from 0 at the beginning, I start, if this is what we added together already, I'm now going to start my loop from here. If we're adding 3 digits at a time, we already did this sum. So now I'm going to start here. I already have a variable with this sum, which is, what do we get? 17. I'm going to take that variable, which is called temp sum. I'm going to add 2, and I'm going to subtract 2, which is stupid because we get the same thing. But then next time through, let's say we're looking at these 3. This is our current sum, which is 17 again. What we do now is I add 1, and I subtract 6. And so then we're looking at 13. No, 12. We're looking at 12. And we take the maximum between max sum and temp sum. So math.max is an easy way to do that. You could also just do an if statement like we did over here, if temp is greater than max. And this just updates max sum if temp sum is larger than what is in max. So this solution allows us to loop over the array 1 time. So if we're talking about 1,000,000 digits in the array, we're still only going over the entire thing once. And we don't have to continuously re-loop with a nested loop. All that we do each time through the loop is a single subtraction. Technically, there's a subtraction in here, but we're subtracting one of the array values and adding one array value in. And that's the sliding window. And it's way better, much more efficient in the grand scheme of things. It's O of n instead of quadratic, O of n squared. Oh, and I should prove that it does indeed work. If we execute it, we get 19. Let me just declutter things. All right, we get 19. And that indeed is the largest sum. What is it, these 3 here? Is that right? Yes, that gives us 19. Awesome. Moving on.